From slidenerd, this is Weaves. Ooh, if you look at this title, you're probably wondering what it means. The perfect number. Now that sounds like a myth, doesn't it? If you take this number 6, which is 1 plus 2 plus 3, you guys will notice something weird. 1 and 2 and 3 are factors of 6, and yet if you add them up, you get 6 back, right? So those numbers, when you add the factors and you get the number back, they are called perfect numbers. Nothing to do with the image background though. So let's go ahead and see. If you have the output, enter the number 6. Yep, it's a perfect number. Enter the number 7. Nope. The program says that. So 7, there are no factors, that is only 1 is the factor. We can take 1 and 7, but we exclude the number when considering perfect numbers case. So let's go ahead and see how this is done. Sum of the factors excluding the number. You have 6, you have 1, 2, 3 and 6, which are the factors, right? So you just take 1 plus 2 plus 3, so it is 6, and that's why 6 is a perfect number. It's perfect. So let's go ahead and see this. The test is something like this. Take a number 6, find all the factors, sum the factors. Is the sum equals to number? Then perfect, otherwise nope, poop. So let's go to NetBeans, get this done. So here in NetBeans I have a buffered reader for taking input from the user. I've already done a video on factors, so you guys can see that. I'll have a link up for that. Enter the number, the user will enter something. So you'll see, I'll take the number divided by everything from 1 to the number, and I'm simply taking result, which is the number divided by I, and just printing it out by saying res. And here I'm also using a function called math.ceil, which is gonna round off my division by removing the extra decimal stuff. So let's just run this and see what happens. Control S, Shift F6. If I put a number like 7, and let me put 6 and see. So as you guys can see, there is 6, okay, there is 3, there is 2, there is 1.5, 1 and 1.2. Okay, now there is something weird you guys must have noticed. Result, math.ceil of result. Now these two are the same in 1, 2, 3 cases, right? For the other cases, that is these two, they are not the same. So these are the factors, right? 2, 3, 6. Let me say I less than equals number. Control S, Shift F6, enter the number 6. Okay, now 1, 2, let's take another number and see. Control S, Shift F6. I'll take the number like 8. So as you guys can see, whenever these two are equal, that is res and ceil, that is this 4 cases, they are the factors. So let's go ahead, print the factors out. I'll say if result equals ceil of result. I always miss the capital M on that one. Ceil of res. Then it's a factor, right? So what we need is the sum of factors excluding the number, right? So let's go ahead and we'll say int sum equals to 0. We'll say sum plus the result int res, and we'll store this thing inside sum, right? In short, we are trying to sum up the factors, like saying 1 plus 2 plus 3 plus whatever, this 1, then add this 2 to it, add the 4 to it, add the 8 to it. That's what we are trying to do over here. We don't actually add the 8 to it, we need to remove it, right? So now this is done. So let's go ahead, go down and just print the sum and see what happens. I'll say sum, Control S, Shift F6. I have a number like 8. Sum is coming to 15, right? If I remove the 8 out of this, it's gonna be actually 7. So I'll go ahead and I'll say at the end I'll remove the number itself, because we don't want the number to be added. We only want the factors like 1. If you take 6, you want 1 plus 2 plus 3, you don't want 6 in that. So we'll say sum equals to sum minus number. Yep, this will remove the number outside it. Now if you print the sum, it's gonna be perfect. Let's see system.out.println. Control S, Shift F6, enter the number 6. As you guys can see, you are getting the sum also 6. Now we can go ahead and say if sum equals number. It's a perfect number, otherwise nope. We don't need the otherwise case anyway. We'll say system.out.println. Perfect. Control S, Shift F6, enter the number 6. It's gonna say it's perfect. So at this point, if you guys wanted to see what a perfect number is, this is done. But I'm gonna go one step ahead, find all the perfect numbers between 1 and 1000. So let's go ahead and do that. I'll put a for loop, say for int j equals to 1, j less than 1000, j plus plus. Now each time I need to calculate or check if it's a perfect number or not. I'm gonna control X this whole thing and put it inside. Alt Shift F to format everything, or you can manually format with your space and tabs. So at this point I have everything over here. Wherever there is number, it's gonna be j, because j is 1, then I test for 1, j is 2, I test for 2, right? So number is gonna be j over here. I'll say j, j and j everywhere. Control S, Shift F6, enter the number. It's asking me what the hell. I'll say 0. So let me go ahead and remove the buffered redo statements. We don't need that because we are simply printing stuff. Control S, Shift F6. Perfect, perfect, perfect. Okay, but what is perfect? J plus, we're gonna print that out and see. Control S, Shift F6. 6 is perfect. 28 is perfect. 496 is perfect. Alright. I hope you guys got the point. If you like what you saw, please subscribe to my channel. Comment. Let me know what you think about this. I love to hear your response. Thanks for watching. I'll catch you guys later. Have a nice day.